Here, we're going to work through a pretty advanced practice problem that asks about limiting reactant and excess reactant. Make sure you have a good understanding of the basics before you tackle this one. We'll use this equation to answer these questions. What is the greatest amount of AlCl3 in grams that can be made with 114 grams of Al, aluminum, and 186 grams of Cl2, chlorine? Which is a limiting reactant? Which reactant is in excess? And how many grams of it are left over? Okay, so to start out this kind of problem, the first thing we got to do is figure out what the limiting reactant is. Is it aluminum or is it chlorine? To figure out the limiting reactant, we got to plug some stuff into this equation. And in order to plug things into the equation, we got to have them in moles. Okay, so we need to ask the question, how many moles of each reactant do we have? Right now, the problem is giving us the information in grams. Grams of Al, grams of Cl2. So we got to convert from grams to moles. All right, so let's start with the aluminum. Okay, we have 114 grams of aluminum. To convert to moles, we're going to want to use the molar mass of aluminum, which tells us how much 1 mole of aluminum weighs. Okay, here it is right here. We can look it up on the periodic table. 26.98 grams per mole, and this thing that I wrote here can be expressed as a fraction, kind of as a conversion factor with a top and a bottom. So I'm going to want to multiply 114 grams Al by this conversion factor. I want to get rid of grams Al. So in order to do that, I'm going to flip the conversion factor. So I'm going to put 1 mole Al on the top, and then I'm going to put 26.98 grams Al on the bottom, right? So it's this, it's just flipped. All right, now I'll multiply through grams Al up here, grams Al down there, cancels out, and I do this times this divided by this gives me 4.23 moles of aluminum. Okay, so that's how much aluminum I have. Now let's do the same thing for Cl2, for chlorine. Okay, I have 186 grams of Cl2. I'll multiply that by a conversion factor that expresses the molar mass of chlorine. And here is that information. Okay, the molar mass of Cl2 is 70.90 grams per mole. We can think of it as a fraction, as a conversion factor like this. I want to get rid of grams Cl2, so I'm going to flip this. I'm going to put 1 mole Cl2 on top, 70.90 grams Cl2 on the bottom, and I'll go through and cancel this stuff. Gram Cl2 cancels out. This times this divided by this is going to give me 2.62 moles Cl2. Okay, so now we know how many moles of aluminum we have and how many moles of Cl2 we have. This is going to be really important information, so we're going to hold on to this thing here throughout the whole problem. Now that we know how many moles of aluminum we have and how many moles of chlorine we have, we can figure out which of these two things is the limiting reactant. Okay? We're going to answer 2 questions to figure this out. First, we're going to ask, to use all of the aluminum, how many moles of chlorine do we need? Then we'll kind of flip that and we'll ask the opposite. We'll ask, to use all the chlorine, how many moles of aluminum do we need? Now, the first reactant that we run out of is the limiting reactant. We're going to figure out which do we run out of first. Do we run out of aluminum or do we run out of chlorine? To give us a little bit more space, I'm just going to get rid of this as we work through the limiting reactant stuff. Okay, so to use all of the aluminum, how many moles of chlorine do we need? Okay, well, we have 4.23 moles of aluminum. I'm getting that from this right up here. And I want to multiply this by a conversion factor that represents the relationship in this equation between moles of aluminum and moles of chlorine. Okay, so it's a 2 to 3 ratio. I want to get rid of moles of aluminum, so I'm going to put that on the bottom. Okay, I'm going to put 2 moles Al. I got the 2 there. And then on top, I'm going to put 3 moles Cl2. And you can see that we're going to be converting to Cl2 because the moles of aluminum cancel out. And the math is this times this divided by this is going to give me 6.35 moles of Cl2. Okay, so what is this actually telling us? Okay, the math here is telling us that in order to use all of the Al, all of the 4.23 moles of it, we need 6.35 moles of Cl2. Okay, so here it is in words. We need 6.35 moles of Cl2 to use all of the Al. Okay, so here is the answer to this part of the problem. Now we're going to ask the same thing, but starting with all of the Cl2, all of our total amount of it. Okay, so we have 2.62 moles of Cl2, of chlorine. I'm going to multiply that by a conversion factor that shows a relationship between moles of Al and moles of Cl2. Okay, I'm going to put Cl2 on the bottom, so I'm going to put 3 moles Cl2 down there. Up here, I'm going to put 2 moles of Al. Okay, mole Cl2 cancels out, and this times this divided by this gives me 1.75 moles of Al. So this shows us that we need 1.75 moles of Al to use all of the Cl2. Here it is in words. Okay, we need 1.75 moles of aluminum to use all of the chlorine. So which is the first reactant that we run out of? Which is the limiting reactant? Okay, check this out. All right, to use all of the Al, to use all of the aluminum, we need 6.35 moles of chlorine. But we don't have 6.35 moles. We only have 2.62 moles of chlorine, right? We don't have this much chlorine. On the other hand, to use all of the chlorine, we only need 1.75 moles of aluminum, and we have more than that. We have 4.23 moles of aluminum, okay? So kind of to sum up what we've just figured out with the math here, we can say this. We can say we have enough aluminum to use all of the chlorine, right? We have enough aluminum. We have 4.23 moles of it. We only need 1.75 moles. We have enough aluminum to use all of the chlorine, but we don't have enough chlorine to use all of the aluminum. To use all the aluminum, we need 6.35 moles of chlorine. We only have 2.62 moles of chlorine. So what does this mean? What does this mean? Well, if we don't have enough chlorine to use all the aluminum, it means that chlorine, Cl2, is the limiting reactant. The amount of Cl2 that we have is limiting the amount of product that we can make. It's the thing that's holding us back. Now we want to figure out how much AlCl3 we can make. All right? To do that, we can't start with all of the aluminum because we don't have enough Cl2 to start with all the aluminum. But we can use all of the chlorine. We have enough aluminum to use all the chlorine. So we're going to figure out how many moles of AlCl3 we can make if we use all the chlorine because we have enough aluminum for that. Okay, so starting with all of the chlorine that we have, 2.62 moles of Cl2. We're going to multiply this by a conversion factor that shows us the relationship between moles of chlorine and moles of AlCl3, aluminum chloride. Okay, so I'm going to put 3 moles Cl2 on the bottom, and then on the top, 2 moles AlCl3. Okay, mole Cl2, they cancel out. The math that we're going to do is this times this divided by this, which is going to give us 1.75 moles of AlCl3. Now we're not quite done with this part of the problem because we're asked the greatest amount of AlCl3 in grams, not in moles. So we got to take this amount of moles and ask how many grams is this, okay? In order to do that, we're going to need the molar mass of AlCl3, 133.33 grams per mole. We can express it as a conversion factor. And just as is, we can use this conversion factor to multiply by this because I have moles AlCl3 on top here, moles AlCl3 down here. So they cancel out just the way that conversion factor was written. And I do this times this divided by this, which is going to give me 233 grams of AlCl3. Okay, so that is the first part of our question, which asked us the greatest amount of AlCl3 that we could make. All right, so it's this. Now, there's one more thing that we have to figure out, and that is which reactant is in excess and how many grams of it are left over. To figure out this excess reactant stuff, we want to go back and we want to ask how much aluminum do we need to react with a maximum amount of chlorine. We did this calculation earlier, all right? We have the maximum amount of chlorine. This is how much aluminum we need to react with, all right? But we have way more aluminum than that. So we have extra aluminum. That means that aluminum is the excess reactant. And we want to figure out, first of all, how many moles are left over, okay? So our excess reactant here is just going to be our total reactant minus the amount of reactant that we used. So we start with 4.23 moles of aluminum. How much do we use? Well, to react with a maximum amount of chlorine, we use 1.75 moles of Al, and that is going to give us 2.48 moles of aluminum. Now this is still in moles, so finally we got to convert it to grams. We can convert this to grams by pulling out the molar mass of aluminum. Okay, so we want to multiply this by a conversion factor that we can make from this information. There it is, 26.98 grams per mole. We can keep the conversion factor just like it is here because moles Al is on the top, moles Al is on the bottom. They cancel out. And the math we're going to do is this times this divided by this, which is going to give us 66.9 grams of aluminum. And this number here tells us that excess, the amount of excess reactant, the amount of excess aluminum that we have left over. So that's how to solve a rather challenging limiting reactant problem. Just remember, the first thing you've got to do with a question like this is figure out which is a limiting reactant, and then you've got to make sure that the numbers that you plug into the equation are always in moles. After that, it's just a matter of figuring out which you run out of first and using the limiting reactant, the amount of limiting reactant, to figure out how much product you can make.